Hello, welcome again. This is Adrien Yodosawa with the seventh part of Introduction to Programming with Python. So this week we are looking into classes, objects, and we will also have a quick look at the modules. Now we won't be talking about pip, but I will quickly mention what is pip and what it does. So last week we saw what classes are and objects. And if we can do a quick recap, we saw that classes are basically a blueprint and objects are what we can make by using those blueprints. So for example, if you wanted to make these three cars, you would make a class, a blueprint of a car, and you would define all the common components, specifically properties and methods which a car is expected to have. And then whenever you create an instance of this class, you would define it would inherit by default all the properties of the parent class, and then you would add any special feature every car has to have, which in this case happens to be the car. So to create a class, we saw that you simply use the class keyword, you give the class name, and then you use a constructor method to assign the instance properties, and these are the properties you can change whenever you are creating a new instance of the class. We also saw that what the methods and properties are. Basically, we saw that methods are like what the object can do, like the behaviors, and the properties are, well, just properties. Now it's important to see the difference between these properties we have here and the properties we define by using the constructor method. Because if you look carefully, you notice that in the constructor method we are accepting name and age, and then we are setting them to these class properties, to these properties. But in this case, when we define the class, we had coded some properties. So these are what I call the class properties, and the class properties are the ones you cannot change when you are creating a new instance. On the contrary, these instance properties, as you see, you can always change them when you are creating a new instance. For example, when I create person 1, I pass in this name and this age. So these two, they get passed into the constructor method and they are saved as properties for this class. But when I hard code them like this, I cannot say, okay, I'm going to create cat1 object, and I will pass in regs equal to 3 or I is equal to 1. It's not gonna work because these are hard coded in. So these are called class properties. The other ones we create with the constructor method are called instance properties. And the methods are basically what the function can do. And remember that all the class methods, they accept self as the first argument, which binds them to the class. And we also saw how we can access the class methods and properties. We simply when we create an instance, for example, called Paul, an instance of student, Paul already has all these properties and methods. So we can say Paul.name, we get the name, we can say Paul.findAge, and we can access this method which is inside Paul. Now for today we talk about inheritance. Inheritance is nothing more than just extending the functionalities of the parent class. So the keyword here is extending. As an example here, I have this class called student, and then I have a class called undergraduate student. As you can imagine, an undergraduate student is a subset of student. So for example, if I also had to create a class for graduate student, instead of coding all the properties and methods of every undergraduate student and every graduate student, what I could do instead is to create a class of student, and then I will put in all the properties and methods which are common to all students. And when I want to create a class for undergraduate student, I will inherit from student. Inheriting means I will take in all the properties and methods which the student class already have. And then should I want to add additional methods and properties which are specific to undergraduate student, then I can go ahead and add them. But the key here is by inheriting all the properties and methods from the parent class, I don't have to reinvent the wheel, I don't have to rewrite them again over and over again. So in this example, student is the parent class, undergraduate student is the child class, and the child class inherits all the properties and methods. And the way we do so is simply by adding brackets, and you place in the name of the parent class, and you will basically be inheriting from it. And you do that when you are creating a new class, of course. I could also go ahead and create another class which inherits from undergraduate student, maybe computer science undergraduate student, and that will inherit from undergraduate student, which itself inherit from student. You can go as many layers down as you want. This is why sometimes when you are writing your OOP code, you have to make sure that it's written in a maintainable way, because otherwise you can end up with a very messy, which is deeply nested, and at some point it might become a total mess when you go too deep. Another thing we wanted to look at is code overriding. Now imagine if you had inherited from a class, but at some point you decide that you want to customize some of the properties or methods which you imported from the parent class. Like in this example, I have the human class, which is the parent class, and I have the baby class, which is inheriting from human. So when we inherit from human, we get this method called greet, which prints hello. But when I inherit from human and I'm creating a baby class, I want to change the behaviors or the output of this greet method. So that's what is called overriding. And overriding is simply done by redefining the method or the property. So if I redefine greet again, and I say now when we call greet, print something weird which a baby might say every once in a while. So the next time I try to do baby.greet, I'm not gonna get the default behaviors of print from the parent class. Instead I will get the new behaviors of this method. So what I did is, by redefining greet method in a child class, I have overwritten what was in the parent class. And that's the idea of functionality overriding. You can do it with methods and with properties as well. And as a quick conclusion now, as we conclude OOP, there's much more to learn about OOP. You can always learn more, but the purpose of this class is to introduce the concepts. So I would like to finish by pointing out that OOP is a programming paradigm. It's not a Python only concept. So you will see this in Java and C++ or the object-oriented programming languages. This is a concept they all share, and it's a very powerful concept. So running it is not only useful when you are coding in Python. Let me put it this way: it's a skill which is transferable across most of the modern programming languages. And the second part of this seventh week is about modules. Now, what are modules? Modules are simply a code library, or in a more understandable words, it's a file containing the functions which we want to use. So I will give you a quick example. Suppose you had a daily job in which you found yourself repeating some boring tasks every day. So instead, what you could do is you could create one file which has all the functions or the cool tools which you use on a daily basis, and every day you come to work you could just reuse those tools. So that's the idea we are trying to do with modules. So imagine, for example, I found myself that on my daily work I write programs which use these four functions: greet, find edge, is even, find every. It could be anything. But suppose I use these four functions quite frequently in my work. So what I could do is I could create a module which, as we saw, it's just a file which has these functions, and every time I need to use them I could just get them from my module. So you could go ahead and create a Python file. You call it the name you want, which will be easier for you to remember. And then inside that file you can code these functions. Just code the functions You could also, by the way, use OOP and create classes whereby every class has methods. And then once you have created the module, now you can actually go ahead and use it. For example, you could come in another file inside the same directory, the same folder, and then you will type import. You put the name of your function. Here, for this to work though, your module file has to be exactly in the same folder as the new file from which you are trying to import the module. So, for example, in this case, I would have one folder which has two files: my module, coolfunctions.py, and another file which I'm working in. Now, from the file I'm working in, I would type import coolfunctions, and I would use those functions. I think I should go ahead and try to demonstrate this. So, I will have two files quickly. I will have these coolfunctions. I think I have it created somewhere already. Yes. So, I have my folder which has several files. By the way, let me delete this for now. I will tell you what it does. I have coolfunctions and I have test.py. Now in coolfunctions, I happen to have these three functions which I saw that for some reason I find myself using them frequently. Now in my new files, I could reuse these functions. I could say import coolfunctions. Now when I do this, I already brought in my module. So since I have these functions in my module, I could say, okay, I could say greet, maybe print, could use the function greet and maybe pass in my teacher's name. And if we run this and everything goes well, we have an error here. And the reason why we have this error is when you choose to use this syntax for importing, when you import the whole module, before you can type your function name, you have to refer to where it's coming from. So this is coming from coolfunctions.greet. So we brought in coolfunctions and we say coolfunctions.greet. So we are using a method called greet which is found inside coolfunctions. So let's run again, and you see this time we got hello teacher, which is exactly what the function is programmed to do in another file. And you could also go ahead and use the other methods which are in your module. Now, as you see, this might be quite wrong. For example, if this was a class and then I had some functions inside it, I would end up having to write like coolfunctions dot some class name dot some functions, and all of a sudden, before you know it, the Python code is starting to look like Java code. So rather than doing this, a more Pythonic way to do it, a more cool way, is to go inside this module and actually pick what you want and bring it. So I could say from coolfunctions import greet. This means go inside this module and bring this function. By the way, if I wanted other methods, I could use a comma and name them. Maybe if I need is even, could bring it in as well, and then I could just use them. I could say, okay, now I don't need to say print coolfunctions again. Now I can just say greet teacher, and it should work just as well. I can say is even and pass in a number to check if it's even. Now let me pass in 4, and 4 is even. Yeah, right. So you can import your function. This is a way I would much more recommend, because when you import everything, then in case your module is really large, then your program might suffer performance issues. So bring in what you need and use it. And also you can also give a nickname when you are importing your functions. In case they have wrong names, you can say, okay, I'm going to import greet, but I will import it as GT. So I'm giving it a nickname, and I can say GT someone. I noticed that I wrote DT. What this does is it will import the function greet, but it will bring it in with a nickname of GT. So when I run it, I should get just the same output as before. Yeah. But when you are using nicknames, make sure that you use them only when it's really necessary, because you might find yourself using nicknames and then struggling to remember what they meant when you are further down in your program, or if someone else is trying to understand your code. So as long as your name is not too large, just import it with its proper name. Now another thing I need to point out is, you notice that whenever I run that code, a certain new folder here was created, which is underscore pycache underscore. So what this is basically is, when we import a module from a folder, what Python does is it will cache that module, it will create a version of that module which is much quicker to use. So what this is basically is, as you see, we have this Python script called functions.py. What it did is it created another version of call functions.py, but which is called bytecode. Now bytecode is it would be like it corresponds to what you get in C++ after you compile your code and now you have the machine code. In Python we have the bytecode, and it's quicker to write and to use, and so that's why it creates this portable file, and it will save it in the folder called pycache. So if you had like 10 modules in this folder, then your pycache file would contain all those modules, so that the next time you want to import them, it will just simply look inside this directory called pycache and bring them in. So because there wasn't this folder at first, when I did the first import, it created it. However, in the future, if I do imports, to just come and press in a new, for example, if I create a new module inside the same directory, it will just add it here as well. So basically, this is a new format of that file, of that module, which is much more usable for the computer. If you try to open it, you would not be able to view it nicely, because it's bytecode. It's not the script code, it's the bytecode. Okay. Now enough with that. And I already mentioned about nicknaming and bringing in a specific function. Oh, by the way, if you want to bring in all the content of a file, you can simply say import star. Import star will bring in all the functions, all the tools inside your module. Okay, so if you don't want to specify, you can do import star. Now we have a practice problem here, which is called managing a bank. And in this problem, using your OOP knowledge, implement a simple application to manage customer accounts. So basically, you ask it to create a class called customer, and then that class will have the following properties: customer ID, customer name, phone, and balance. And it will have these methods: a method to update the name, a method to update phone, to check the balance, to send money, and to receive money. And then there will be a homework problem, which is basically a slightly more complicated version of the practice problem. So let's go ahead and solve the practice problem together, and then the homework problem you can try it on your own. So we ask you to create a class of customers. So we begin with that class customer. And this class needs the following properties: customer ID, customer name, phone, and balance. Now, since we will be creating multiple bank accounts, we don't want to hard code these properties as class method. Instead, we want to use the constructor method to initialize them, and it takes in self, and it will be accepting the customer ID. Let's say, let's simply say ID. This is conflicting with a Python built-in keyword of ID, so let me not use that word. Let's just say customer ID, make it as descriptive as possible. It also needs a customer name. We need a phone, and we need a balance. Now for the balance, we could say the default, we could set the default to 0, so that in case you want to create a bank account with no initial deposit, the default balance would be 0. Now once we have received these inputs, we need to set them to the properties of this customer class. So the way you can do this is you can simply say self.id is equal to customer ID, and self.name is customer name. I kind of like to keep my code clean. And self.phone is equal to phone. Self.balance, now that's equal to balance. And I could just bring it together, all of it. Put this, come here. Yeah, I think that looks cool. Now every time we create an instance of this class, we'll be accepting these arguments, and we set them to these properties. Now with properties, it's done. Now we need to implement the methods. The methods, as we saw, they are simply functions. The first method we need to implement is the update name. So we can define it, update name, and I call the other class, the other methods. It accepts self as the first argument, which binds it to the class, and then it needs what? So to update the name, we don't need anything. We only accept self, and then what we do is we update the name to the new name. Actually, we do need something else. We do need the new name. So upon receiving the new name, we set self.name equal to the new name which we just got. And that's all this method needs to do. The second method is update phone, which, same as the previous one, it accepts self and the new phone number. Let's call it the new number. And all it does is it sets self.phone to the new number. The third method is the check balance. So we define check balance, accept self and nothing else, just need to return the balance. So it's return balance. And since for check method, for this check balance, actually we might as well just go ahead and display it on the screen by printing it. Self.balance. Since if we wanted to grab the value, we could simply grab it from self.balance. So we don't need the method which returns the balance. We just need the method which prints it on the screen. So we can print it. And now the remaining methods are the practical one, sending and receiving money. Let's begin with receiving money. Define receive money. So it accepts self, and then we need to accept the amount which we are receiving. Now once we receive this money, we can say, okay, self.balance, we can increment self.balance by amount, which is the same as saying self.balance equal to self.balance plus amount. It's just the same as incrementing the amount which we just got. Now for the send money method, we need to be careful because we don't want to send money which is more than what we currently have. So we need to press a check before sending money to make sure that we are sending money which we have. So we need to check if amount has to be less than or equal to the self dot balance we have at the moment. If that's the case, then only then we will transfer the money. We say self dot balance, we decrement by amount. If that's not the case, then we know we have a problem. We can tell the customer that they have insufficient fund. And we can actually give them a useful message. We can tell them how much more money they need to top up their accounts to be able to perform this transaction. I think that would be quite useful. So let's use f string here. You can say please let's just say you need some more money to make this transaction. Now the amount of money they need is the amount they want to send minus the balance they have, self dot balance. So we tell them you need this much additional money to make this transaction. Okay, you need additional. You need an additional this much to make this transaction. Okay, that would be useful. And this is pretty much it. So now it's about the time we actually go ahead and test our class and see if it works as expected. So to test this class, I will write simple test here. Let me maximize the view. So I need to create some instances of that class. I will simply create customers, several customers. Let's say customer 1, let's go to customer, and he needs an ID which we say is 1. He needs a name which is Bob, and he needs what again? He needs the phone number which is going to be 00444, and he needs some initial amount which is going to be 1000. Now we can create other customers as well. And we can give them different IDs. Finish, we don't want to give them the same IDs to be disaster, and we can give them different names. Alice, Bob 2, Alice 2. Bob and Alice are very popular in programming. Alice 2, Bob 3. Now I will just be changing one number here to make their numbers different. Now for the amount, actually for some people I could completely ignore to send this input because the amount will be initialized at 0 by default. And if everything works, I should be able to run my program and load it in memory and be able to interact with this program. So now I run my program. Now I can go ahead and start testing it. So I can say, okay, customer 1 dot name, and his name is Bob Free, which is weird, and the reason why it's weird is because I set all these customers the same variable, which is very buggy. Okay, let's solve that and run the program again. We repeat what we did. Customer 1 dot name, we get Bob. Customer 2 dot name, we should now get a different name, Alice, and you see it's working. Now we need to check the properties to see if they are working as needed. For now, let's first check, for example, customer free dot balance. You see their balance is 0. Let's say they just got the money. Let's say customer free dot receive money, and let's give them 10k. So if this worked, if we try to check their balance again, we should not get 0, we should get 10k this time, which worked as we wanted. Now let's say this person wants to transfer money. So customer free dot send money. He can send, for example, if he has 10k, he could send 1k to someone. And by doing this, we trust if we check their balance again, it should now be 9k, I guess. Yeah, right. Now let's try to send money much higher than what we currently have on the account and see if it works. So instead of sending 1k, let's attempt to send 10k. Okay, let's attempt to send 10k, which definitely should not be possible because we only have 9k at this point. Yeah, you need an additional 1k to make this transaction, which is cool. So our program works, and this is how you would do it. Now take a quick look at this code before I close it, and take a snapshot if you can, or hit pause, because you are going to use these ideas for the practice exercise. Okay, now I trust you have taken a screenshot, or use the pause button to take a quick copy of it. Now I want you to practice this problem. Now build on that previous code and add these following additional functionalities. Now, as you saw, we were creating several customers. I want you to try to implement a data structure and then store all those bank accounts. And the reason I want you to do this is because I want you to try to support back and forth money transfer among our customers. For example, if we have customer 1, customer 2, customer 3, I want you to try to implement the functionalities to transfer money from customer 1 to customer 2 and back and forth and so on. And I want you to make it so that if customer 1 sends money to customer 3, the next time customer 3 checks their balance, they should get the new balance after having received the money. Now, that being the case, I also want you to add a pin property, so that every time someone tries to check the balance or to transfer money or to do something, you will ask them to enter a pin, and you will check if the pin they entered is correct. If it's correct, then you will perform the transaction. If it's not correct, you will tell them that their pin is wrong. And lastly, this one might be quite challenging, but it's really useful in practical situations. I want you to see if you can create a log file, a log text file, and every time there is a transaction, just save this transaction in a log file. For example, you have one file and it has multiple lines. Every line represents a transaction which happened at some time. Maybe customer 1 sent 1k to customer 2, and every time a new transaction happens, you create a new line in that file and you save it. So go ahead and try to see if you can implement this. And don't be frustrated if you can't. Keep running, and once you feel more confident in OOP, just come back and try this question. So this is the end of our 7th part. We talked about OOP and modules. And I didn't talk about pip, but pip is simply a package we use in Python to install the other people's library, or the open source libraries. We just saw how to create libraries, and that's the cool thing in Python. You can create libraries and you can use other people's libraries. So since we have all those public libraries and packages and everything, we need some sort of standard package management tool, and that's what we call pip in Python, which is Python package manager. In JavaScript, you have something called npm or yarn, and I believe other languages have their own package managers as well. So if you do a quick Google search, you can see what pip is all about, and we simply use it to install packages. For example, one framework I use a lot is called Django, and the way you install Django is you open your command line and you basically type pip install Django, and that way do it. So I won't be talking about pip a lot because I believe you can learn about it from Google. So thank you so much for attending this, for watching this part until the end, and congratulations for completing it. I hope to see you in the eighth and rest part of this introduction course to programming. Thank you again.